Welcome. Today I want to talk about enumerations in Go and TypeScript. First, why enumerations? Well, strings are a bit too flexible. This value could be anything, including my favorite dog's name. So therefore, in many cases, it is useful to restrict the values, let's say to these 4 values. Let's compare enumerations in another reasonably type-safe language, TypeScript. TypeScript is the type-safe dialect, if you like, of Node.js. So let's click onto this link, courtesy of TypeScript Playground. So this is how you describe or declare an enumeration in TypeScript, north, east, southwest. We can do the same thing with string enumerations, north equals north, etc. And if we run this program, the first output will show the type of dir, which is a number, and the type of dirs, which is a string, S for string. So as you can see, it's number and type is number, the value is 0, string value is east. Alright, let's close this and go back to the slides. How does enumerations work in Go? Let's look at the main program. I wrote a package, it's named compass. So D is a direction, it's compass east, and /t is the type, %t is the type, %v is value, integer value, and string value. Yeah. If I run it, let's make this a bit more readable. So if I say compass east, its integer value is 1, the value is actually east, and the string value is actually east. If I go to north and I run my code again, it's 0 and north. So that's how enumerations in Go works. Let's dig a little bit deeper behind the scenes, dig into the compass package. So Go actually does not have an enum keyword, and enums in Go are implemented with integer constants. So that's the package compass. I have a global type or public type directory, so it's compass direction, not directory. This is not really a command, it's a directive. It looks like a command, but it's /go generate. I'm using another utility named stringer to convert these integers, actually direction is an integer, into strings. So that's why the command is called stringer, and you actually install it with this command, go install, etc. And this package is very, very simple. All it does is has these constants, and these constants are directions, and iota begins counting. It's an auto-incrementing integer, begins counting from 0. So 0, 1, 2, 0, 1, 2, 3, where's value is 3. So let's see how type-safe TypeScript enums are. Alright, so here I have the number version of the enum. Direction is compass north, and I say direction equals 2. Let's see if this runs. Yep, it runs. How about 2.2? It still runs. Not very type safe. The maximum value is, I believe, is 3. How about 45? Still runs. Not very type safe. How about the string enums? Are they type safe? So here's the string version of TypeScript enums, and straight away an error is flagged. Type east is not assignable to type the string. That's good. Let's comment. Well, instead of commenting it out, let's try, like I indicated, directory string west, just for the fun of it, and run it. Now no errors. Now we know why TypeScript enums are usually string enums and not integer enums. It's a lot more type safe. Next on the topic would be, well, let's check type safety of Go enums now. Let's try it. So D is compass north, D equals 2. Do you think it will compile? Do you think it will run? Let's try it. No errors, it ran. But 2 doesn't look very type safe to me. Well, actually it is. This 2 is an untyped number. And when we assign it to D, it became compass direction. If we cast it to int, let's say int 1, or, well, let's try int 1, it will fail. It will fail. Let's try a non-existent number, 45. Don't know, I've never run it before. Apparently it's a compass direction 45. It's a string value, we don't know, it's some unknown direction 45. But if it's direction 3, it will work, string west. And if we say compass direction 3, well, that was a shortcut. This is making it explicit. It will also work. And let's make it 2, for example. And it runs. Of course it does. Right. So why are we concerned about enums? One process is passing enums to another process over the network. So let's see how enums are serialized to JSON. So I've got the integer or the number version of enum for TypeScript here, and JSON stringify, and the string version of the enum and JSON stringify. If I run the program now, this is encoded as 0, the integer 0, or the number 0, and for the string version is encoded as north, as expected. But they are now strings. Alright. Let's see if Go can do any better. So that's the entire program. Let's see what's the representation on the network, shall we? If we run it, it's represented as 0. Well, not very descriptive at all. And it's not Go's fault, it's not TypeScript fault, it's the serialization format, JSON. It's just not very comprehensive, if you like. How about we use a different serialization format with GOB encoding, Go object encoding. It's a standard library encoding. So I have a network which I simulate with a buffer, a bytes buffer. So the encoder is a GOB encoder. My direction is compass north. I make sure I can encode it. If not, I fatal out with the error. Let's see what's actually put onto the network. Then on the receiving side, I have the direction output as a compass direction. I decode it. If there's an error, I'll fatal out. And let's see whether it can extract compass north accurately. If I run it. So on the wire, it's got this binary format. when it's decoded, it's fine. Let's change this to west, which I think the value is 3. Yep, it is. It works perfectly. So more comprehensive serialization format like GOB and potentially, I think, protocol buffer would achieve this level of integration as well. So that is my short introduction to enums and comparing them with enums with a TypeScript as well as a Go implementation. My name is Yu Yin. I work for Zendit, and Zendit is hiring.